The information in this video is based on the most current information available at the time of production. While affordable safety training works hard to make sure these materials are current, the employer has sole responsibility for compliance with all laws, regulations, and standards. This video is sold with the understanding that AST is not providing professional or legal advice. Employers should have a reliable source for current regulatory information and best practices.
In 1914, the United States Radium Corporation was founded. They manufactured radioluminescent paint products, used on glow-in-the-dark watches, dials, and instruments. The war was on, and demand was huge. U.S. Radium hired women to paint the radioactive material onto the dials. Management and scientists used gloves, masks and screens to protect themselves. The women were provided no protection, and were instructed to wet their brushes with their lips. They were exposed to cadmium, radium, thorium, uranium, vanadium. As illness, deformity, and death occurred, U.S. Radium claimed it was from sexually transmitted diseases due to the promiscuity of the women. These women had no express legal right to know the hazards of the chemicals they were working with. You do. You have the right to know. Use it.
Chemicals are used frequently in the workplace for tasks such as manufacturing, maintenance, and cleaning. The employer has the responsibility to communicate the hazards of these chemicals to workers, and provide the materials, personal protective equipment, and work practices necessary to keep safe. The Occupational Safety and Health Administration implemented 29 CFR 1910.1200, which regulates the communication of chemical hazards in the workplace. The title of this rule is Hazard Communication, but it is frequently referred to as the Right to Know. OSHA has aligned its rules with the Global Harmonized System for Classification and Labeling of Chemicals. This system is commonly referred to as GHS, and it applies to the format of safety data sheets, and the labeling methods for chemical shipping containers. The objectives of this lesson are to 1. Understand the OSHA requirements for hazard communication. 2. Understand the requirements for safety data sheets. 3. Understand the requirements for chemical labeling. 4. Understand the requirements for employee information and training. The purpose of hazard communication is to make sure that all chemicals produced, or imported, are evaluated, and that information concerning their hazards is transmitted to employers and employees. All workers must be informed of the chemical hazards in their work area, and be given the knowledge, and means, to protect themselves from injury or illness. The Hazard Communication Standard requires chemical manufacturers to assess the hazards of their products, prepare and provide safety data sheets, ship chemicals in containers with proper GHS labels. The regulations require employers to provide a written hazard communication program, make safety data sheets available to employees, label chemicals properly, train employees on hazard communication, and maintain a chemical inventory. The Hazard Communication Standard applies to businesses with employees who are exposed to chemicals during normal work conditions, or foreseeable emergencies. Chemicals include liquids in containers, substances in pipes, fumes, and solids, gases, or vapors. There are many chemicals that people don't typically associate with hazard communication. The cutting of solids, like wood and metal, the exhaust fumes from vehicles, and substances in pipes, all require hazard communication compliance. There are 4 major routes of chemical exposure: inhalation, ingestion, absorption, and injection. Inhalation is the breathing in of fumes, vapors, dusts, and particles. It is the most common form of exposure in the workplace. Many employees do not even realize they are being exposed to chemical hazards. Have you ever smelled wet paint? You are being exposed. Some types of inhalation exposure can be very difficult to detect, such as carbon monoxide. Workers tend to ingest chemicals when they get it on their hands or clothing, and then put their hands near their mouth. Smoking, eating, or drinking with chemical contamination on the hands are common examples of chemical ingestion. Absorption can occur when chemicals come in direct contact with the skin. If you look at a safety data sheet, you will see that protective gloves are required for nearly every chemical used. Injection can occur from sharp objects such as needles or cutting tools. High-pressure air or fluid systems can also be the source of injection exposure. The basic hazards of chemicals are classified into two categories: physical hazards, and health hazards. According to OSHA, a chemical has a physical hazard if it has any of the following characteristics. It is a combustible liquid, a compressed gas, an explosive, is flammable, or is an organic peroxide. Physical hazards also include oxidizers, pyrophorics, unstable reactives, and water reactives. To put it simply, if it can ignite, burn, explode, cause chemical burns, or start dangerous reactions, the chemical has a physical hazard. A chemical has a health hazard if acute or chronic health effects may occur as a result of exposure. These chemicals may include carcinogens, toxic or highly toxic substances, reproductive toxins, irritants, corrosives, sensitizers, hepatotoxins, nephrotoxins, neurotoxins, and agents that can damage the blood, or lungs, eyes, skin, or mucous membranes. The health effects of a particular chemical will be listed on its safety data sheet. While there are many different types of health effects, just remember if it can interfere with your body's normal internal functions, it is a health hazard. Some substances have health effects that target specific organs. Hepatotoxins target the liver. Nephrotoxins target the kidneys. Neurotoxins target the nervous system. Reproductive toxins target the reproductive system. If you have a medical condition that makes a certain organ prone to damage, or are planning on having children, you should pay special attention to the target organs listed on the safety data sheet. Chemical exposure is classified into two basic types: acute exposure and chronic exposure. Acute effects from exposure happen immediately. Vomiting, burning, and coughing are all examples of acute exposure. Chronic effects happen over a long period of time, and are often more difficult to detect. Cancer, emphysema, and hearing loss are examples of chronic effects. Chronic health effects from chemical exposure can, in the long run, pose the highest risk to employee health. The symptoms of overexposure often take years to develop, and sometimes the cause of the illness is not identified until it is too late. The permissible exposure limit is the maximum allowable exposure established by OSHA. They usually have a time-weighted average limit, and a peak exposure limit. The PEL can be found in Section 8 of the Safety Data Sheet. Most of the OSHA PELs have not been updated since they were created over 50 years ago. Some of them may be dangerously out of date. For example, toluene is commonly used as a thinner for paint. The OSHA limit is 200 parts per million for a time-weighted average of 8 hours. The American Conference of Governmental Industrial Hygienists recommends a limit of 20 parts per million. That is 10 times less than what OSHA allows. Fortunately, with the new safety data sheet format, these other recommendations are listed along with the OSHA limits. Read them carefully, and remember, a legal exposure level is not necessarily a safe exposure level. You should always know what level of exposure you are receiving, and what level is considered safe. The employer must maintain a list of the hazardous chemicals in the workplace. It must be kept with the Hazard Communication Program, and be readily available to all employees. The name of the chemical on the list must match the product identifier on the safety data sheet. The list can be for the entire workplace, or it can be broken down by work areas. Make sure that every chemical in your workplace is listed on the inventory. An incomplete chemical inventory is a very common OSHA citation. Consider adding checking the chemical inventory to your chemical receiving work process. Safety data sheets provide the information and precautions required to work with a chemical safely. Every chemical in the workplace must have an SDS. If there is no safety data sheet, the chemical may not be used. Employees must have immediate access to the relevant safety data sheets for their work area. They can be kept in a binder, in work procedures, electronically, or other methods, as long as they are available to workers. Make sure you know where the safety data sheets are kept for your work area. Safety data sheets have 16 different sections. They are: identification, hazards identification, composition of ingredients, first aid measures, firefighting measures, accidental release measures, handling and storage, exposure controls and personal protective equipment, physical and chemical properties, stability and reactivity, toxicological information, ecological information, disposal considerations, transport information, regulatory information, and other information. Section 1 of the Safety Data Sheet is for identification information. It includes the product identifier. The name on the chemical inventory, and the name on the container, must match this identifier. This section also includes other names used, the recommended use of the chemical, restrictions on use, company contact information, and emergency contact information. Section 2 contains the hazards identification. This section includes the chemical classification, the signal word, the hazard statement, precautionary statements, and the unclassified hazards. Section 2 will be very helpful when you are creating chemical labels for your work area. Most of the information required for those labels can be found in this section. Section 3 is for composition of ingredients. It includes the chemical name, common names and synonyms, CAS numbers, other identifiers, and the mixture information. Section 4 is where you can find first aid measures. This is a very important section. You should be familiar with it before you work with a chemical. It's hard to read a safety data sheet when you have chemicals in your eyes. It also includes symptoms of exposure. If you are feeling sick, you can check this section to see if it is related to the chemical you are using. This section also includes medical attention and special treatments required for overexposure. Section 5 contains the necessary firefighting information. This includes proper extinguishing agents, hazards from a chemical fire, and special PPE required for firefighters. First responders and designated firefighting brigades should be familiar with the requirements of this section. Section 6 contains the accidental release measures. It will tell you the precautions, protective equipment and emergency procedures for handling a spill. It also includes methods and materials for containment and cleanup. This is where you will get the information required for your spill response procedures. Section 7 contains information on handling and storage. It describes the precautions for safe handling, the required conditions for proper storage, and incompatible materials. This section is very useful when setting up chemical storage areas. It will tell you where, and how to store the chemical, and what chemicals should be kept apart so they do not react. Section 8 might be the most important section of the safety data sheet. It includes exposure limits, appropriate engineering controls, and required personal protection measures, such as PPE. This section will tell you what exposure levels are allowed, and what equipment and PPE you need to protect yourself. Remember that the OSHA PEL is not necessarily the most current information on safe exposure levels. This section is also popular with OSHA inspectors. If they see employees working with a chemical, they will flip open the safety data sheet to Section 8. If they are not wearing the required PPE, that will be a violation. Section 9 contains the physical and chemical properties. This includes appearance, odor, pH, flash point, flammability, solubility and viscosity, plus many more. Section 10 includes the stability and reactivity of the chemical. In this section you will find information on the reactivity, chemical stability, possible hazardous reactions, conditions to avoid, incompatible materials, and hazardous decomposition. The section should be consulted when making decisions about where a chemical is placed in the work area, how it is transported, and how it is stored. Knowledge of this information can prevent a dangerous chemical reaction from occurring. Section 11 covers the toxicological information of the chemical. The information includes toxic health effects, symptoms related to toxicity, acute and chronic effects, measures of toxicity, and if it is a carcinogen. Section 12 lists the applicable ecological information. It includes ecotoxicity, persistence, degradability, soil mobility, and other adverse effects. This information is especially important if there is a chance the chemicals that are used can be released into the environment. Section 13 describes the disposal considerations for the chemical. It provides a description of waste residues, safe handling practices, methods of disposal, and disposal of contaminated packaging. Many chemicals, such as oils and hydraulic fluid, are discarded after use. This section will tell you how to handle the waste, and the preferred methods of disposal. Pouring it down the drain is almost never the appropriate method. Section 14 is especially important to companies that transport chemicals. This section covers the required transport information. It includes the UN number, the UN shipping name, the transport hazard class, environmental hazards, and special precautions. Employees who ship or receive chemicals, and employees who transport them, should be very familiar with this section for each chemical they work with. Section 15 contains the regulatory information. This section will have relevant safety and health regulations, as well as the applicable environmental regulations. While useful, this section will not offer a comprehensive list of all regulations. You still need to be familiar with the regulations that are specific to your region. Finally, Section 16 covers any additional information the manufacturer wants to communicate. It includes the date of the safety data sheet creation, the last revision date, and may include things such as suggested labels or NFPA information. If there is important information about the chemical that was not covered by another section, you will find it here. The safety data sheet contains all the information you need to protect yourself from injury and illness. You should be familiar with every safety data sheet in your work area. Place special emphasis on the nature of the hazards, engineering controls, required personal protective equipment, how to perform first aid, and how to handle a spill. It is your life. Protect it by committing this information to memory. Here are a few tips for managing safety data sheets. Keep them current. The SDS can change, make sure you have the most recent one. Also, make sure every chemical has an SDS. Keep them organized. Many workplaces have SDS binders that are stuffed full and covered in dirt and grease. This is important information, keep it organized. Remove old safety data sheets. SDS storage is not meant to be a record of chemicals that were once used in the workplace. If it is no longer used, get the SDS out of the binder. Checking for a current safety data sheet should be part of the process of receiving a chemical. You can also add information from the SDS into your work procedures. The more integrated they become in your daily routine, the more useful they will be. All chemical shipping containers must be labeled with GHS-compliant shipping labels. They must include the product identifier, the signal word, which is danger or caution, the hazard statement, precautionary statements, pictograms, and the responsible party contact information. The person responsible for shipping or receiving chemicals must verify these labels are in place. The globally harmonized standard established 9 different pictograms for describing chemical hazards. The relevant pictograms must be on the shipping label. Pictograms may also be a part of your workplace labeling system. Here are the 9 pictograms. Health hazard for chemicals that are harmful to health. This pictogram indicates the substance is flammable. The exclamation point indicates the chemical is an irritant or it is toxic. The gas cylinder means that the chemical is a compressed gas. The substance, and hand, getting an acid burn, represents a corrosive. The exploding bomb means that the chemical is explosive or reactive. The flaming O represents an oxidizer, which is a chemical that other fuels require to burn. The dying fish means that the chemical is an environmental toxin. And the skull and crossbones indicates that the chemical is a poison. These pictograms are an important part of the hazard communication system. Get familiar with them, you will see them in the workplace frequently. All chemical containers in the workplace must be labeled. There are two methods allowed for chemical labeling. You can use the information from the shipping label, or you can use the product identifier, that matches the safety data sheet, plus words, pictures, symbols, or a combination that provide information on the hazards of the chemical. Every chemical, even common cleaners, must be labeled. We will take a close look at each of these labeling methods. Using the information from the shipping label is the easiest method for chemical labeling. It is not as subjective as the other method, and it meets OSHA requirements. It also provides comprehensive chemical information to employees. Companies also have the option of creating their own labeling system, as long as it complies with OSHA. Here is how OSHA describes the criteria for custom labels. They must have the product identifier, and words, pictures, symbols, or combination thereof, which provide at least general information regarding the hazards of the chemicals, and which, in conjunction with the other information immediately available to employees under the Hazard Communication Program, will provide employees with the specific information regarding the physical and health hazards of the hazardous chemical. While this method does give the employer more flexibility, it opens the labeling method up to interpretation, as to if it is sufficient to protect employees. Let's take a look at a few examples. For this example, we are using ammonia, and using the shipping label information as the method of labeling. We start with the product identifier, which matches the name on the safety data sheet. We then add the 4 pictograms listed on the SDS. Next is the signal word, which is danger. After that we add the hazard statements, the precautionary statements, and then the manufacturer contact information. Now we have a complete and compliant label. Note, by using the shipping label method, we did not have to make any judgment calls about what should be on the label. Now let's build a custom label for the same chemical. The only specific requirement for custom labels is that they must include the product identifier. We have added the relevant pictograms, leaving out the environmental toxin pictogram, as it is not relevant to this work area. We kept the signal word and the hazard statements. In order to emphasize the PPE, we added PPE pictures that list the specific requirements for personal protection. We also added a section highlighting the required first aid. The manufacturer's contact information is not included, because it can be found on the safety data sheet. Now, is this a compliant label? It may be compliant, if this information, combined with the written program and safety training, communicates all the information that is required to provide adequate protection for employees. Portable chemical containers do not have to be labeled if the chemical was transferred from a properly labeled container, and the chemical will be used immediately by the person who performed the transfer. Examples of this are, pouring cleaners into a spray bottle, or transferring paint to a metal can, or roller tray. It is important to remember that as soon as a portable container is left unattended, it becomes a secondary container, and labeling requirements apply. This is a common OSHA violation. While unlabeled portable containers are permitted, it is usually a good idea to just make sure every chemical container is labeled. National Fire Prevention Association labels are often found on chemical containers. These are for fire prevention and emergency response. They do not, by themselves, meet the requirements for hazard communication labeling. Now for a quick review on labeling requirements. Chemical shipping containers must have a GHS shipping label. Secondary containers must have either the information from the shipping container label, or a custom hazard communication compliant label. Portable containers do not require a label, as long as the chemical in the container was transferred from a labeled container, and the person who performed the transfer maintains control of the container. Employees must be informed of the requirements of the Hazard Communication Standard, the operations in the work area where chemicals are present, and the location and availability of the company hazard communication program, the chemical inventory, and the safety data sheets. Employees must receive training on the methods used to detect the presence or release of hazardous chemicals, the chemicals in the work area, how to protect themselves from chemical hazards, and details of the company hazard communication program, including labeling, safety data sheets, and how to obtain hazard information. This training must be conducted at the time of the initial work assignment, and whenever a new chemical hazard is introduced into the work area. Every employer with chemicals must have a written hazard communication program. This plan contains the policies for communicating chemical hazards and safety precautions to employees. A lack of a written hazard communication program is usually the most common OSHA citation. The hazard communication program contents must include the policies for chemical labeling, the method and location for storing safety data sheets, employee information and training, a list of hazardous chemicals present, the methods for communicating hazardous non-routine tasks, and hazards of chemicals in unlabeled pipes. Hazard communication is the method that employers use to communicate the chemical hazards of the workplace to employees. Every chemical in the workplace must be properly labeled. Safety data sheets are required for every chemical and must be readily available to employees. Employees must be trained on chemical hazards and the methods for protecting themselves from the hazards. Every company must have a written hazard communication program. Hazard communication gives you the legal right to know the hazards associated with chemicals in the workplace, but it is up to you to use that right. Review the safety data sheets and know how to protect yourself.